Chapter 1, Lesson 7. Okay, so the formulas of the geometric series, remember we're doing addition now. So you got your geometric pattern, and you're adding the pattern. Just like we did the arithmetic series, we're doing geometric series. Again, this is a formula in your thing. It's going to be your S sub n for geometric. Okay, so we still use S sub n notation. So when the terms of geometric sequence are added, it's a result known as a geometric series. So again, the difference, your sequence versus your series. Okay, and then just kind of go right to, these are actually kind of hard to prove, to be honest. So they don't really prove this as much. But essentially, here is your formulas for geometric series. So you need A, R, and N to use this one. A, R, and N. And then we have an alternate one as well, just like we did for arithmetic. Nothing to write down yet. If you think you're behind, there's nothing to write down yet. So however, when the number of terms in the series is not known, so this is when you have the end, but you don't know what term number that is, you can use this one again. So it's a T sub n. That is one thing I'll just mention on your concept quiz. A couple of you guys, when it's that 77, you called n. That's not n, that was T sub n on your quiz. Okay, we'll talk about that later. But remember, T sub n is the number you see there, not the position. N is the position. Okay, so like the 12th term, okay, versus what is the 12th term? It's 80 or whatever. Okay, so anyways, T sub n, that's when you don't have the position, okay, so the actual n. So let's look at these. So they want to show this real quick here. So they want to show that these two formulas are the same. So just proving they're the same real quick. It's not too hard to work, actually. So if we say S sub n, we're going to come from the A. So S sub n is A times R to the n minus 1. That's an n all over R minus 1. Okay, and what we're going to do is we're going to distribute the A. So I'm starting from this here, and I'm going to make it look like this. So I'm going to distribute the A. Okay. And what we're going to do is, we're doing a little move you probably wouldn't expect to do. We're going to take out an R. If I take out an R, what's the exponent change to? So if I have R sub, like R to the n, and I say I want to pull out an R, what would you change the exponent to? No, but you're on the right track. You're thinking correctly, but we don't have to do that much. It's a little easier. Here, what? Well, what's this? What's on it? A 1. So we took a 1 out, right, with the exponents. So it would be minus 1. Now, if you take a 1 out, it's like subtracting 1 from it. You're pulling one of the exponents out. Okay? So it would look like this. So you have R times AR to the n minus 1. And now we're done because, correct. Took one of them out. Does this look familiar? That's T sub n, right? Your general term in geometric is AR to the n minus 1. So now we can sub this in to get to here. R T sub n minus A over R minus 1. So we got there. Okay, just a little proof why they're the same, why they both work. Okay, is that relevant in terms of you need to be able to do that? I'd say no, but it's good to see that it's not magic, that they're actually cohesive. Okay. All right, so let's use some examples here. Pretty much just using the formula now, okay? So determine the sum of the first 15 terms of the sequence -5, 10, -20. So what is A? It's -5. What is R? Looks like it's -2. And what is N? They want 15. So we have A, R, and N, so we can use the first formula. The formula again would be this. I'll write it one more time here. That's the formula. So for S sub 15, we want -5 times R, which we said was -2, to the N, which is 15, minus 1, all over R, -2 minus 1. And that's just a calculation from here. Just make sure you have your brackets. A couple things. Make sure, simplify this. Make sure the brackets down here, it's -3 down here, etc. Okay. So when you calculate this, you should get -54, 615. couple of reasons I feel good about this is because is the 15th term negative or positive? Yeah, it's negative, right? Because all my odd terms are negative, so I'm having a big negative down here, which means that's why it took over and it's a big negative answer. So you can go and tell me then that S16 should be what type of answer? Positive, right? Because it's going to take it back over because it's going to be bigger again. Okay, good. Just little positive, negative issues with geometric. Okay. Any questions? Here? 5. Yeah. Okay, sorry. Term of the sums, this one, we got 4, negative 12, plus 36. So I just want you to do this series. So we are doing, do we know what that is? Like an n? Right. Well, we don't have to because we can use the other formula. Whoops, that's all right. We don't need that. Yeah, we don't. Correct. Let's move this up anyways. Okay, so yeah, we're going to go the second formula. So we're going to use the S sub n equals R T sub n minus A over A, whoops, over R, not A, R minus 1 again. Okay, so again, our A is 4, our R is negative 3, and our T sub n, what we need, is negative 8748. So we have everything we need to plug that in. You could, yeah, it'd be a little more guess and check, right? When you solve for n, you have to kind of do a little bit of guess and check. We don't have the skills yet to do that. So here are negative 3, t sub n, that big negative 8748. Oh, I forgot the 4. That's okay, you guys see that. And then minus a, so minus 4, all over negative 3 minus 1. And that's just a calculation. You get negative 6560, which again we feel good about because that big number we went to was a big negative. Okay. Okay. All right, so let's go look at 4 now. This is where the algebra comes into play. You got to have to be able to be workable within the formulas. So the sum of a certain number in terms of a series is negative 2, 8, negative 32 is this. So the sum of this pattern to some number is that. So we know the series answer, but we don't know the ending term. So what is the last term that make this series add up to negative 104, 858? So what I really want you to make sure you understand, do we want n or t sub n? T sub n, very good, very important clarification there. The last term is t sub n. They didn't say where is it, they said what is it. Does that make sense? It's not saying what term number does this go to, it says what is the actual number there. Okay, so very important to pay attention to that wording there. So what we're going to do is, since we're talking about t sub n, we're going to use the R t sub n formula. So we're going to use this one again. Okay, because we have everything but t sub n. And I mean everything, because we know what this is. What is s sub n? Right, the negative 104,858. So we put that in there. Okay, we know r looks to be negative 4. We don't know t sub n. We know a is negative 2, so minus a would be plus 2, because minus a minus, all over negative 4 minus 1. Okay, so I plugged that in there. I'll give you a second. Okay. What are you going to want to do to solve here first? Because now, remember, we're solving for t sub n, so don't lose track of what we're trying to get here. We're trying to isolate. Oh, dang it. We're trying to isolate t sub n. So what do I want to do? So when I look at this, if I'm you, or just in general, the fraction bar is really frustrating me. This is like blocking me. So get rid of this so the fraction bar is gone. So I'm going to get rid of, this is negative 5, okay? So we're going to go by negative 5 to both sides. That's your first step. So that cancels. Okay, that gives you 524, 290. And now you should feel a little bit more comfortable because you are negative 4 t sub n plus 2. You have a two-step solve now. Minus a 2, divide the negative 4. Minus a 2, divide the negative 4. Okay, like that. So we get 524, 288 equals negative 4 t sub n. And now we divide by negative 4 to finish. So t sub n, which we expected t sub n to be negative, is 131,000. 131,072 negative. That would be the last term for to have that series. Okay. Any questions there? Sure. Okay. All right. Let's go and do this last couple. We'll get a couple of those bouncing ball problems coming as well. But let's do this last one here for this page. All right. So geometric sequence. The fifth term is 1024. So let's just kind of write this down. So t of 5 is 1024. The common ratio is 4. Find the sum of the first 7 terms of the sequence. So we want to find s of 7 is what we're trying to figure out. Okay. So what do we need to do in order to do this problem? Because there's something that's in both formulas we don't have here either way. Yeah, we don't have a. We have to find a. So in this case, we have to get a. Okay. Both formulas corner us to having to have a. So how can you get a? Well, this is enough information because we take the general form. Okay. We have all the stuff but a. 1024 can go here. If I'm using 1024, then my n is 5. And we know my r is 4. So there. That's an a there. So 1024 equals a, 4 to the 4th. Right. So if you divide 4 to the 4th over, you're going to get, what is 4 to the 4th? Is it 256? 256, yeah. So we got 1024 equals 256a. Divide it, and so your a is 4. So now we're good to go to use the formula now. We have everything we need. So for your formula, we would use the s sub n one. We're using that one. So we are doing right here? Yeah, because it's n minus 1, so 5 minus 1. Because in terms of the general term. Is that okay?
When you go 10 or 1024 divided by 4, you have 5 times.
So when you do 1024 divided by 4, you get what? 0.25. Okay, what do you mean by 0.25? Like, where are you getting 0.25?
Dividing 1024 by 4 5 times.
Oh, yeah, you're doing it 5 times, but it needs to be 4 times, though.
Oh, yeah.
See what I'm saying? So, yeah, that's why. Yeah. Okay. It's all right. Okay, so then we plug it in now. So we have a, where are we at? A is 4, excuse me. And then r is 4, so that's kind of confusing, but 4 to the n is 7, because they want 7 terms, minus 1, all over 4 minus 1. So there's your calculation. And this gives you 21,844. Okay. Yeah, this one we had to use get a first, right? Okay. All right, so a couple more here. Couple more. good. Okay, so determine the number of terms of the geometric series. So now we're trying to find the number of terms since we're looking for n. So solve the sum of the n terms of series 5, 15, 45, all the way up to 16,400. Is determine the number of terms in the series by solving the equation with a common base. Okay, so we're going to figure this out. First off, we have a is 5. We know its r is 3. And we know the series, because it says the sum, the S of n is 16,400. We just don't know where it's at. Right. What's that? So we're going to use well, let's plug in what we have first and see. There's kind of two ways, because let's do common base. Since we don't know where it stops, we can't really use that formula, so we don't know what that n is, and we don't know where it stops. So we have to use a series formula, because that's the information we have. Yeah. Okay. Sorry. Yes, except for this time we have n as a problem, though. So yes, we do we're using this formula here. So the n is in the exponent. So we know that when we get down here, we're going to have to use our calculator or guess and check on this one is my point. Because n, we don't have the skills yet to get the variable off the exponent. Okay. So we're just going to do our work here. 3 minus 1 is 2, so I'm going to multiply 2 to both sides. So that gives me 32,800 equals 5 times 3 to the n minus 1. We're going to divide the 5. It gives me 6560. Okay, and then we're going to do add 1, 6561, 3 to the n. And now we're trying to figure out 3 to what power is 6561. 3 to what power is 6561? 8, good. So 3 to the 8th is 6561, so n is 8. Okay. All right. Okay, yeah, so I'm going to skip the graph and calculator part for now. Again, what you would do is you would just go y1, y2. Okay, you would simply put 16,400 in y1, and you would put 5 times 3 to the n minus 1, all bracketed, divided by 3 minus 1, or 2. Okay, and you'd find the intersect point of those graphs, okay? And it gets you 8 again, yes. The same thing for your calculator.
You can do that way.
Yeah. Yeah, that's a sound way for right now, finding n, yeah. Okay, and then maybe after the video, I'll show you guys that again. I just don't want to put it on the video for right now. Okay, so golf balls dropped. So again, this is a problem I told you it's going to be a common occurrence. It's good because it has a sequence and a series component. But a golf ball is dropped from a top building 100 meters above the paved road. Each bounce, the ball reaches the vertical height of 3/4 the previous vertical height. Determine the vertical height of the ball after the 7th bounce. Okay, so after the 7th bounce. So I'm going to let Rieger, why don't you decide, what do you want your T1 to be? You can decide. Do you want your T1 to be 100, or do you want your T1 to be after the first bounce? Okay, so his T1 then is going to be 75. Because 100 times 3/4 is 75, right? 3/4. So remember, this is about knowing where you are. So if his T1 is 75, just illustration if you're confused, here's the building. It's 100 meters high. It comes down, it hits, and then it comes up to here. That's 75. So that's the height after the first bounce. So as of now, my T1 is bounce 1, so I want, in this situation, T7. So I'm looking for T7. Okay, so so if T1 75, so that's my A. What is my R? 0.75 or 3/4. Okay, and then we want N to be 7. We're ready to go ahead and figure out this. This is not a series problem, is it? This is a sequence question. We're trying to figure out the height at that sequence. Okay, so we're using our general form. We're using this. So t of 7 is 75 times 3/4, or 0.75, to the 7 minus 1 to the 6th. You should get 13.3 meters. Okay. Any questions with that? Now, this question is a really good one because now you really have to think about the full context of the question. Okay? I'm going to kind of actually do some of the work above here while I have this picture. But the total vertical distance to nearest 10th traveled by the ball when it contacts the floor for the 7th time. So when it contacts the floor for the 7th time. So what does that mean?
It means the first one it has to be 100 meters.
Okay, good. So yes, you have to count for 100. Okay, and this is the total vertical distance. So if I go up, I have to come down, right? So everything else has a what? A pair. Everything else has a pair of it happening. Because we didn't go up to 100, right? It dropped.
Yeah.
So the 100 is kind of a separate entity here. And then it goes up 75, down 75. Up 3/4 of that, down 3/4 of that. It continues. Now when it says touches the ground for the 7th time, how many rings am I going to have? So what I mean by that is, this is bounce 1, right? See, that's 1. Here's 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6 up and downs. So I'm saying is, see how it contacts the 7th time? Did it do the 7th bounce? No. So we're really looking for the 6th bounce. Does that make sense? So we have 6 sections. The way I like to look at this, we have 6 sections. Okay, 1, 2, 3, 4, 5, 6, and the extra 100. Okay, so you really have to dissect this in terms of that. But you have the symmetry of the up and the down. You have the 100 to add on. Okay, so since I've drawn that, let's just stay here. I'll try to do the work right here. So we are going to do 100 plus double what? Double series 6. So what that does is, if I do series 6, what does series 6 mean for the context of this question? Just the series 6, nothing else I wrote. What does S of 6 mean? What will that do for me? Add them, and what is them, Kenzie? Correct. So you're right, it'll add them. But if I do just S6, that adds the ups, right? Every up. And so the double gets the down for me. That's why I have the double, okay? And then plus 100. So we're ready to go. So let's do it. So we got 100 plus 2 times, so S of 6. So S of 6 is going to be 2 times, so 75 times 3/4 to the 6th minus 1 all over 3/4 minus 1. And that's what we're going to calculate right there. So there's your S of 6 formula, doubled for the up and down, add the extra 100 from the drop of the building. And we do that, you should get 593.2 meters is the distance traveled. Okay, pause the video there, let you kind of ask about that, think about it. All right, so extension of this question in part C, how many times the ball needed to bounce to travel 675? So it says travel, so that means that's my S sub n output. So that means with our formula, we know 675 is over here. We know it's 100 still. We know it's still doubling the series formula, but we don't know what n is this time. So we know 75 still. We still know it's 3/4 for R. We don't know n anymore. And we know it's 3/4 minus 1 here. And so we need to solve for n. This is how we're trying to figure out the total distance traveled okay, by the bulb. All right, so what we're going to do is minus the 100 first. You get 575, okay, which equals 2 times the 75 times 3/4 to the n minus 1 all over 3/4 minus 1 is negative 1/4. Okay, so 2 over negative 1/4 is negative 8, just FYI. So if we move that over, it should give me, let's see here, so we should have, trying to think what they did here. All right, so 2 divided by negative 1/4, negative 8. What's 575 divided by negative 8? Somebody do that for me? Negative 71, okay. 72, yeah, okay, I got it now. So negative 72. So the reason I got this right here is negative 8, okay? 2 over negative 1/4, because 2 divided by negative 1/4 is flip and multiply. So 2 times negative 4 over 1. So I just divided that there. And then now we have 75 times bracket 3/4 n to the minus 1. And see, we're going to divide the 75 now. And that gets me, I think it's 23 over 24. Yeah. That reduces negative 23 over 24. And we're almost done to the part we're going to use a calculator. And we're going to add 1. So negative 23 over 24 plus 1 gives me 1/24. So this is the part where you're not equipped to get the n down. So you could guess a check if you'd like and try to find it close. Or you have to use your calculator. This one you probably use your calculator because it's not going to come out cleanly. Very clean, I mean. So I'll do that with you now. So on my calculator, I'm going to put this in y1. I'm going to put this in y2. Okay, so here we go. So 3/4 to the x in y1, 1 over 24 in y2. Here's the window I have if you want to copy this. Negative 2 to 20, 2. It's not the best window, but we'll be able to see it here. 1 e to the negative 4. I could probably change that a little bit if I wanted. But it's just, that's 0.004. Okay, just making, or 0.001, excuse me. Just making sure that I can see my, because 1 over 24 is a pretty small number. So I'm making my scale really small. Okay, and so this is what my graph looks like. And that bold line here is because the 1/24 is so close to the x-axis, it looks like it's together, but it's not. So if we just hit second trace, number 5, first curve, just make sure it's on a curve. Just move it around, make sure it's on something. Okay, it's on my curve one there. Second curve, see how it jumped? It's now on the 1 over 24 line. So just hit enter, and then it says guess. So just go kind of close to where you see them getting close together. It's pretty forgiving about this. And so there's your answer. So 11, okay, 11 bounces is essentially the answer. 11 bounces when it's going to basically get that point of, what was it, 675. Okay. Any questions? Okay, if you have trouble with the calculator, I can come show you that. I'll do that soon. It's not hard. Just need to practice it. Okay. All right. So, okay. So let's finish this up here. Consider the geometric series defined by S sub n, 5 times 3n minus 1. Find the first 4 terms of the geometric series defined by that. So this comes back to something we struggled with in our quiz, right? We have to remember that, don't forget, S1 equals T1. S2 minus S1 equals T2. S3 minus S2 equals T3. Okay? So you always can use series to find terms. Okay? So if we do that, we can plug this in. This is the formula for the series, so we simply have to plug in a 1. So if I find what S1 is, it's 5 times 3 to the 1 minus 1. 3 to the 1's 3, minus 1's 2, 5 times 2, 10. So term term 1 is 10. Now find what S2 is. S2, 5 times 3 squared minus 1. 3 squared is 9, minus 1 is 8, times 5 is 40. 40 minus 10 is 30, because S2 minus S1. Okay, it wants the first 4 terms, so we'll do all the way up to 4 here. 5 times 3 cubed minus 1. 3 cubed is 27. Minus 1 is 26. 5 times 26 is 130. 130 times 40 is 90. So we already know what the pattern is doing, don't we? What's it doing? Timesing by 3, yeah. So we kind of know what's going to happen here. So S4, 5 times 3 to the 4th minus 1. So that's 81, which is 80, times 5 is, 81 minus 1. Yeah, I was right. So 400, sorry. Let's get 400. 400 minus 130 is 270. So there's your first 4 terms. And that was a struggle you guys had on the quiz yesterday. And we'll talk about it in a little bit. Find T9 without using the formula. So that means they want you to use S of n. So they want you to do S of 9 minus S of 8. That's what they're asking you to do. They say without using the general term. So S of 9, 5 times 3 to the 9th minus 1, minus 5 times 3 to the 8th minus 1. That gets you kind of big numbers here. 98,410 minus 32,800 finishes with 65,610, okay? Just practicing the series. And they put that formula down there for the bottom again. All right, one last question. Okay, so this one we're going to use the calculator again probably. So scientists plate E. coli bacteria on a petri dish. At the end of the first hour, 30 bacteria cells are present. The number of new bacteria cells produced each hour forms a geometric sequence. If the total bacteria cells is 40,950 are present at the end of 6 hours, use the technology to determine how many bacteria cells are produced in the 6th hour. So the 6th hour, they're trying to give, we want to know what T6 is. Okay, we're trying to find T6. We know the first hour, so we know A. A is 30. We know the total, that means a series of 6 hours. So we need S of 6 is 40,950. Okay, so what are we missing? N, yeah, we don't know, we know N. N is 6, sorry. R, we don't know how it's doubling or tripling or growing. Okay, so what we want to do is we want to set up our series. So we're going to use this guy still. A times the R to the N minus 1 all over R minus 1. And so we have 2 issues here, 2 R's, I mean. So we know that S of 6 is 40,950. We know that A is 30. We don't know R, but we know it's 6 for N. Minus 1 all over R minus 1. Really can't do much here. You really can't do much here. So we're going to go ahead and move to our calculator here. So this is going to be Y1, this is going to be Y2, and I'll help you set a window as well. Okay. So by getting R, though, is R the answer? No, they want to know the term of 6. So just so you're clear, I'll put this back up here again. We're trying to figure out what T6 is. So A, R to the N minus 1. So we're trying to figure out what 30 times what to the 5th would be, like the R. Okay, so let's try it here. Okay, so bring this back up. I'm going to change my Y we're going to put this in here. So you're going to put 40,950 in there. Use brackets here. Okay, brackets are important when you're doing fractions. So bracket 30, another bracket x to the 6th minus 1. Close bracket, so that's my numerator. Divided by bracket x minus 1. Like that. Okay, any question on that? Let you get that, and then I'm going to adjust the window with you. We need much bigger than the last one, so we're going to have to adjust. Okay? So the window we're going to use, we're going to change our, so hit window. We're going to change our x min to 0. We're going to go to 10 by 2s. The y is going to be the big one. My y min, we're just going to stay with 0 because we don't have anything negative for bacteria. And my max is going to be 50,000. Okay, and since I have 50,000, my scale, we're going to go by 5,000s. That's a scale we're going to use. Okay, let's see what it looks like here. Nice clear picture. We get that's what we're going for. That's the answer of when they intersect. So we had second trace, number 5. You really don't have to hit enter 3 times here. It does it pretty easily for you. So the answer is 4. Okay, so the rate R is 4. So that means it's quadrupling each hour. The bacteria is quadrupling each hour. Okay, if you didn't quite get the calculator part, I can help you with that in a second. For the sake of just finishing, I'm just going to figure out what my T sub 6 is now, okay? So 4. So we know to finish the problem now, we want to figure out what T of 6 is. So T of 6 is 30 times 4 to the 5th, which gives you 30,720 cells were produced in the 6th hour. Okay? All right, so that's all for that one.